Yeah. Good morning, dear students. Today we will discuss pointers here. We are starting fifth unit. Okay. So far we have covered first four units of syllabus, leaving a couple of topics which probably can be discussed the other way around afterwards. But now we'll today discuss about pointers here. As you know, pointer is a derived data type, and it is basically a very helpful data type which is used to hold the address of another variable of the same type. The other way around, we call it as a placeholder, right? Which holds the address of memory location of another variable of the same type. Okay. A variable that holds a memory address. This address is the location of another variable in the memory. A pointer is a variable whose value is the address of another variable of the same type, as I discussed, right? How do you declare a pointer, rather, right? With the help of this asterisk, you can see here. Can you see, all of you? This asterisk, asterisk is here used as an indirection operator, which is probably been used as a okay. So asterisk data type asterisk followed by the pointer variable. That is how you generally declare the pointer. You can see int asterisk p int a equal to 10. If I have taken, then if I have to point to a with the help of pointer p, then first I have to assign the address of a to p. You can see the address of a ampersand will give you the address, right? Address of a you are placing in p. So that what happens now? Let us say for a, as we know that memory is going to be allocated, right? Whose value is 10 here, rather, right? And whose address, let us say some 100 or whatever. So this address you are placing in P, then what happens? P is pointing to this particular memory, right? So you can access this particular variable or memory location with the help of A, and another way of accessing the same is using P. This is called indirect way of accessing, rather, right? That's how exactly here presented. You can say if you were to say, for example, A, whose address is 1001 taken, and P is a pointer for which also memory is going to be allocated. How much memory is going to be allocated for pointer? It's only 2 bytes, rather, right, to hold the address of memory location, right? So it holds the address of what when you say P equal ampersand A is nothing but address of it. 1001 will be placed in P. P is now holding what A's address, right? So P is going to act as an indirect way of accessing this particular memory location, right? Each memory will have, as we know, the name, value, and the address, right? So even pointer will have some address. Pointer is also associated with some kind of address, as I said, some memory, as I said, 2 bytes of memory, right? Whose address, let us say, for example, 1003. The address of pointer is 1003, but the value of P is also an address, but that is the address of A. So with the help of P, you will be able to point to A. Fine. So P is a pointer here which is pointing to the address of variable A. Data type of P and A should be same. It's a condition, right? As I said, the pointer will hold the address of another variable of same type. It means A and P both should be of the same type. Right? Pointer can have three kinds of content in it. Okay, the address of an object, which can be re-reference, a null pointer. The value of a null pointer is of course zero, as I said. Like invalid content also sometimes it can hold, right? So here this operator asterisk, which is being used to access the value at the address, right? Value at the addresses. Asterisk will act like value at. Okay. Asterisk is a unary operator, also called as an indirection operator. Of course, this ampersand is the address operator, as we know, right? With the help of which you can fetch the address of variable and then assign the same to a pointer, so the pointer can access that particular memory indirectly. Ampersand is also another operator that returns the memory address. Okay. The size of any pointer is how many bytes? 2 bytes, right? The benefits of pointer using pointer is pointer are more efficient in handling arrays and structures. Pointers allow references to functions and thereby help in passing of functions and argument to other functions. Right. For example, taking that which we have discussed before, A and P, right? Asterisk P, when you say, is nothing but value at P. Value at P is nothing but the address of A was held by P, which is nothing but A's address. It means asterisk P means it is the value of A. You can see it is the value of A. Yes or no? So when I say asterisk P, which is nothing but the value of A, right? And when I say ampersand A is nothing asterisk ampersand A. See, ampersand A means address of A. Address of A is nothing but the memory address of A. Then asterisk when you say value at that address is nothing but again value of A itself, right? When I say ampersand A, there is nothing but address of A, which is equivalent to P rather, because we have assigned it to P. So address of A there rather, right? Got it? Address of A is 1001. If I say asterisk ampersand A, asterisk ampersand A, okay, ampersand A means the address of A, that is 1001. And when I say asterisk here, then it is nothing but 10. Got it? When I just simply say ampersand A, which is nothing but 1000, 1001, okay. When I say asterisk P means value at this address. Value at this address is what 10 again, rather, right? Okay. Similarly, when I just say P is P. What is the value of P? It's nothing but address of A there, rather, right? When I say ampersand P, it is nothing but the address of P. Yes or no? When I say just ampersand P here, ampersand P means the address of P, right? When I just say P is nothing but the value of P, which is nothing but what? Which is nothing but address of A. Yes or no? So this is the differentiation between A and P here. Now looking at the arithmetic of pointer, the kind of operation that you can perform are only increment and decrement. By incrementing the pointer, you can point to the subsequent, memory, units. And similarly, when you are decrementing, you can be able to point to the predecessors of that same rather, right? Arithmetic rules. What kind of operations that are not allowed on pointer are like, we cannot multiply or divide pointers, we cannot add or subtract two pointers, we cannot apply bitwise operators on them, we cannot add or subtract type float or double to or from pointers, right? What are the benefits of pointers? Pointers are used in situations when passing actual value is difficult or not desired the other way around, right? To return more than one value from a function. Generally, from a function, with the help of return statement, how many values you can return? Only one value. But then with the help of pointers, you can return an array of elements, a structure of elements that probably we'll see in the subsequent examples, right? They increase the execution speed. Okay. Now coming to type of pointers, we have white pointer. The advantage of having this white pointer, it can be able to point to any kind of data, rather, right? It is a pointer can point to any kind of data type. Basically, when you are declaring a pointer, you need to specify the pointer data type at the time of declaration itself. But for white pointer, you don't specify, but it can be used for any kind of data type, rather, right? Can hold over the same execution for some time integers, the other time it can point to double and other pointers like that, right? We can see with the help of an example in the subsequent slides. Okay. So its length is always undetermined. When you have a white pointer, as I said, integer pointer or character pointer, yes. But then for a white pointer, it is undetermined, right? Typecasting or assignment must be used to turn the white pointer to a point of concrete data type. See, when it is declared as a pointer, then the kind of restrictions are going to be imposed at the time of declaration, so, and it is clear for the user that this particular pointer is going to be used for what kind of data. But then if it is a white, then it is not clear that it can be used for what. It can be used to which it can be used to point to what type of data, rather, right? But then at the time when you are trying to point to that respective memory reference, you need to specify the type clearly. that is said to be casting, typecasting. So typecasting has to be done at the time of pointing the concrete data type with the help of this void pointers, right? Like look at this particular example. In this example, you can see here you have a variable a, right? A equal to 5, and you say what happens for a, some memory could have been allocated. How much memory is going to be allocated? It is, since integer 2 bytes of memory going to be allocated, and whose address, let us say 100 for example. A value, when you say 5, so a value 5 is going to be placed here. When you say double B, then for B, how much memory as per our double data type, it requires 8 bytes. Okay, so 8 bytes of memory been allocated, but let us look at only the first byte. First byte will always help you to point to the entire memory, which is, they call it as base address rather, right? So whose value, let us say 3.14 initially, so it is 3.14. Okay, now you have created one white pointer. This is a white pointer here. So now let us say, for example, while printing this a equal to, in place of a equal to, in place of this percentage d, this percentage d is going to be replaced with this particular value. So, but then what is that you have said here? You can see vp equal to ampersand a. Vp equal to ampersand a means vp is holding the address of a. Address of a is 100 here, let us say. Right? So then VP is pointing to whom? It is pointing to A. So when I just say asterisk VP, it has to give me the value of A rather, right? But then while accessing, you need to impose the restrictions with the help of this typecasting. Int asterisk, then you say VP, right? This is how exactly taking the typecasting into consideration, making the white pointer in a concrete kind, right? While accessing with the help of this white pointer, any concrete data type, we'll have to do this typecasting before we access rather, right? Now you can see over the same execution, VP equal to ampersand B. When you say now VP is holding B address, that is 200. So when it is replaced with 200, now VP is no more pointing to this particular memory, rather it is pointing to this particular one, rather, right? So in that case, now when you say double, when you are saying asterisk VP, which value is going to be printed? This value is going to be printed, rather, right? So double asterisk is with the help of which you are able to impose the restrictions with the help of typecasting before accessing that particular data, concrete data to which this particular white pointer is pointing. I hope this is clear to all of you, right? Another kind of pointer is a null pointer, right? It is a pointer that points to nowhere. It means there is no value at all. There is no memory at all. There is no other valid pointer to any other variable or array cell or anything else will never be equal to, ever be equal to a null pointer. So generally, when the pointer is pointing to nothing, we say it is a null, right? It's a constant identifier which is equivalent to 0 in most of the programming languages like C or C++ and all. Null is a value that is not to point to any location in the memory the other way around. Fine. For example, you have a program here. In this, you can say asterisk p equal to a pointer you have created and whose value you have assigned as null. Then when you are printing, then what it prints actually? Memory addresses, when you are printing, what is the format specifier to print the memory addresses? That is percentage u. While we were discussing the format specifiers, I've even given you all type of data for which what can be the format specifiers are going to be used now to read a print rather, right? So for memory addresses, as I said, that is percentage u. Fine. So now coming to array of pointers. As I said, pointers will are more helpful in accessing the arrays and are pointing to structures and probably the entire array, entire structure. If you want to point, or you want to pass as an argument to a function, or you want to return from a function, all such kind of thing that you can probably efficiently do with the help of the pointers, right? An array of pointer is an indexed set of variables in which the variables are pointers, a reference to a location number, right? So if I take one array, let us say here array of 7, array, when you declare what happens for all such 7 element memory is going to be allocated based on its data type, which is integer. So 2 bytes each memory is going to be allocated for each of the element of the particular array. So these elements are going to be pointed with array of 0, array of 1, array of 2, like that, right? With the help of indexing manager, you can access any of the element over this particular array with the help of a single name, that is array, right? So the elements addresses, every memory will have the unique address, as we know, right? And as we know that array elements are going to be stored in contiguous locations. So if take the first element address is 300, as we know integer requires how many bytes? 2 bytes. Then this requires 2 bytes. The first byte address is 300, the subsequent byte address is 301. Then the next element address will start from 302 rather, right? Like how the subsequent element will be 304, 306, 308, like that. Okay, so the offset between these addresses is nothing but 2, because the address the number of bytes required for integer is 2 rather, right? So now here you have taken one pointer that is p, so whose value here you have assigned with array of 0. Array of 0, if you look at, arr of 0, which is nothing but as I told you, this is ampersand area of 0. Okay, just correct it. So when I just say ARR, when I just say ARR, array name also will hold the base address. Okay, 300 itself, right? So when you say ampersand array of 0, it's also nothing but 300. That's the reason why when I was discussing the arrays, I told you the array name is also acting like a pointer the other way around, right? Because array name holds the base address of the array. Fine. So if I say ampersand array of 0 or p is equal to ARR, so what happens is the base address of this particular array will be placed into p. So p is now pointing to this entire array. So with the help of this p also I can access this entire array. So let us look at this example of array of pointers where we have declared one marks array. See, at the time of declaration, you can initialize the array like this. Based on the element that you have initialized, the array size will be decided. So since we have initialized three elements here for this array, so array size becomes 3 here. So marks of 0, marks of 1, marks of 2, these are the array names, array element names, and then the values that you have assigned to them are print 20, 30, whose addresses, if say for example starts from 600, then subsequent element addresses are going to be 602, 604, like that. So you can see a int asterisk point of 3. This is one pointer I am taking, right? Then I is a variable here. So we are assigning the addresses. Marks of 0 is this one, right? Ampersand marks of 0 is nothing but 600. So marks ampersand marks of 0 you are assigning to point of 0, like that, with the help of I varying with 0 till 3. All such array addresses are now assigned to pointer. Then what happens with the help of this pointer also you can point. It's just something like an array of pointers are being created here, and you can see the this array elements addresses are correspondingly stored in this pointer array. So I can access with the help of this point array all these elements. So when I say point of 0, it is pointing to this particular element. When I say point of 1, it is pointing to this particular element. When I say point of 2, it is nothing but pointing to this particular element, right? So when I am printing here with the help of this array uh, of pointers, I am able to access all these array elements and then printing the same value, right? Pointer to an array. You can have pointer to an array, right? That is, for example, a string. Like before, we were declaring a string with the help of a character array, right? And I say character name of 20, then 20 character, array is going to be created, which is going to be pointed through name. So all these elements are pointed through name of 0, name of 1, like that. The last element is going to be when after read null pointer, rather it is. Okay, so when you want to read or print this array, we call it as a string. So we just use a percentage s format specifier in order to read or print. So we can do that all with just the name itself, rather, right? So here you can have, if I just say name asterisk name of 3, then asterisk name act like a pointer to 3 character arrays here, right? 3 character arrays. So it means this name is a pointer which is pointing to 3 strings of this kind, which is equivalent to this, right? When I say character asterisk name of 3, which is nothing but character name of 320. See, name of 20 is nothing but one string. So an array when I say name of 3 of 20, it means array of strings, right? array of strings. So it means it holds three arrays, three strings the other way around, right? Three strings of length equivalent to 20 each rather, right? So this particular array of string you can rather declare it with the help of pointers like this. Both are same the other way around. The advantage of using this pointer here in this case is what happens here in this case, three arrays are going to be created, each equivalent to how many, 20 character length, right? Each equivalent to 20. Whether you use it or not, this 20 character length string will be available associated with you, fine, once it is declared rather, right? But in pointers, if the same thing, if you are implementing it with the help of pointer, the advantage is it just creates a table or an array of three, strings, and each will hold the address of a string the way around. So this string memory is going to be allocated based on the number of characters that you input during the runtime. So if I have inputted only Arun, only for Arun the memory been allocated, and the last one is a null character which is going to be returned to this particular location. So this location is going to hold the base address of Arun. Similarly, if I am inputting the next string as Ravi, is also having only four characters, so it's only four character length memory is going to be allocated, and whose base address is going to be returned in the second field rather, right? That way. So this particular table of pointer is holding the address of the strings rather, right? So the advantage of having these pointers in order to point to these three different things is, see, if I am inputting only Arun, Ravi, we know 3 plus 4 plus 5, 3 plus 4 plus 5 is going to be how much? 12. Only 12 character length is going to be allocated during the runtime based on the need. But whereas here, if I am going with this, the same Arun Ravi, we know they have inputted with the help of this particular array of strings. But then what happens is 20 character length for each is been allocated already. So 23 is going to be 60 character length memory was been allocated here, though you use it or not. How much, of course, out of which you are utilizing only 12, right? So the remaining 48 character length still been associated here, which is being unused. The other way around, I can say it is ineffectively utilized rather, right? But whereas using pointers, what happens, only 12 character memory being allocated for this particular variable, right? It is pointer to an array. So what happens is you are able to rescue 48 character space from being allocated to this particular variable, which can be rather utilized for something else. So that way, what happens is effective utilization of memory can be done with the help of pointers when you're using pointer to an array, right? Another example here given here, you can see taken one character pointer, fine, and a name, right? So here what we are doing is we are entering the size of array, and then once you read the string here, that string is been assigned to the PFI, the address of that particular, in PFI. Then with the help of pointer also you can rather print the same, right? So you can use the pointers to hold the addresses of those strings, and then use the pointers to print the same the other way around, right? So you can pass the command line arguments. You may have seen so far only main was having parenthesis empty because you are not passing any argument through command line, right? Command line is through dollar when you are executing, the program. You are how do you execute the program? Dot slash a dot out, you say, right? So while executing the program, you are not passing any argument. You can pass now arguments. Is they are said to be command line arguments, right? So the first argument is argument counter. Second one is number of strings that you are passing, right? So here it's a pointer array. Pointer array means you can pass any number of strings here, right? So using this kind of approach, what you can do is you can rather develop the device driver programming. You have a copy command, right? CP is a copy command in Unix. You can give the source file and the target file. Then source file is going to be get equipped with the target file, right? Target file is going to be copied into the source file. That's how exactly what happens. The copy command kind of programming you can rather write here with the help of this command line kind of thing. Or move command is there. So all this device level programming you can probably do it fine with the help of the command line argument. So these command line arguments will help you to take the inputs from the command line while the program being in execution. That arguments here you can probably use it for copying files or other kind of thing. Here, let us say whatever the argument that I am passing, that I'm just taking and then printing in this kind of example. Right? Pointer to a pointer. You can have a pointer to a pointer that is multiple in direction the other way around we can say, right? So here you can see a is a pointer. When you have double pointers we take double asterisk into consideration, right? A is a variable here whose value is 100 and whose address, let us say 2156. Now p is a pointer here who is holding the address of a, that is 2156, means p can point to a here, p can point to a here. But now p pointer address is 3156. That if you are placing in, let us say here in q becomes a double pointer, right, to a. Q is a pointer holding the address of another pointer, where this pointer is holding address of another variable. Condition is all must be of the same kind rather, right? So with the help of this Q, when I say double asterisk Q, what it points to a value the other way around. Right? Single asterisk Q, when I say, it points to the value of P, which is nothing but the address of A. When I say double asterisk Q, which is nothing but equivalent to A, right? Because it is pointing to the P, then from there again it is pointing to, because you have double asterisk. First asterisk will take you to P, second asterisk will take you to A, right? So this is how you can probably that you can see here double asterisk q equivalent to how exactly it is a, fine. So a's address is held in p and p's address is held in q. So double asterisk q, when I say, it is equivalent to a the other way around, right? So you can have pointer to pointer, that is double in direction. So here, now to demonstrate the same with the help of an example is mentioned here. A equal to 100 asterisk p as double asterisk q. This is how you declare a double pointer, right? Double asterisk q. So p is holding the address of a here. Q is holding the address of p. So when I print double asterisk with the help of a double asterisk q, it prints a value the other way around, right? You can demonstrate this. Printf, if I say a, then it prints a. Printf asterisk p, when I say, it prints what? It prints a value itself. When I say double asterisk q, it also prints a value. When I say ampersand a, we can say it is printing the address of a, right? 2156. When I say asterisk q is nothing but what? P address rather, right? Fine. P value is nothing but a address the other way around, right? Returning pointer from a function, you can probably have pointer value to be returned from a function, with the help of which you can probably return a big set of values from a function, right? So you can see here in this example, point max is a function which is taking two arguments. See, both of them are pointers here, fine. So here you wanted to find out the maximum out of the argument that you have passed to this particular function. So both of them are pointers here. So let us take a and b. These are the two variables of whose values are 10 and 4. When you call this point max function, it is returning a pointer itself. So taking two pointers as argument and returning a pointer. So pointer as an argument will are nothing but taking the addresses of the particular variable, while the function is being called. This kind of function is said to be called by reference function, right? Reference is nothing but what? The memory. When you are referring the memory, when you are passing the address of the memory, is said to be the call by reference, right? So when you are calling this function, you can see here what is that you're passing point max. You're passing the addresses of a and b. Notice, for example, a and b you have whose values are 10 and 4, whose addresses, let us say, 100 and 200. Then what is that you're passing when you're calling this point max function? You're passing the addresses of a and b, right? So to this pointer x and y, right? X is a pointer here and y is also a pointer. they will take the addresses, right? So A value is nothing but 100 that you're passing when it is passed, it is stored in X, and address is nothing but 200 is placed in Y, right? Then you want to find out the maximum out of this X and Y. So you can see here asterisk X greater than X asterisk Y. If this condition is true, then X is going to be written, otherwise Y is going to be written, rather, right? But then X and Y here are nothing but what? The addresses. So the return type is also for this particular function, you can see is you know pointer. So when the return type of the function is a pointer, then how do you specify the return type? Int asterisk, right? When I just return a value of integer, then I say just int. But then I am returning here the addresses. X and Y are the addresses, rather, right? They are the pointers. So if when they are returning, when you are returning the pointers or the addresses of the memory, then it should be int asterisk, the data type followed by the asterisk, right? So here you can see the value which is going to be returned based on the comparison, whichever is max is going to be written here. So that value will be printed with the help of this pointer p. So this pointer p actually, gets what? The address of whose address, whichever is greater out of this, whichever is greater, a is greater. So a's address must have been written. That is nothing but x value must have been written here, rather, right? So when you're calling this point max value, so p value must have been 100 and is nothing but pointing to a. When you are saying asterisk is nothing but a value is going to be printed, rather, here. Okay. This is what exactly the call by reference, as I said, right? Passing pointer to function is nothing but what? Call by reference. Fine. While calling the function, if you're passing values to the argument, we say it is a call by value that we have seen already, right? If you are passing the addresses, because while you're calling the function, if you have an array as an argument, also in before classes we have seen array name we were passing, array name was holding the address. So that's the reason why we said that one is also called by reference. Fine. Here, when we are passing pointer explicitly, it is nothing but the address of the memory itself. So we say it is a call by reference explicitly, right? So you can see here swap example is mentioned. This swap example is taking two pointers as argument, right? X and Y. Both of them are pointer. You're taking a temporary variable into consideration. We are swapping the values pointed by X and Y. So what is happening? A and B, these are two variables. So for two A and B, so memory going to be allocated 2 bytes each here. Then you're going to read some values into it. Let us say, for example, 10 and 20, whose addresses, let us say 100 and 200. Then what is that you're going to pass here? You're going to pass here, you can see A and B addresses while you're calling the swap function, because swap is taking what? Pointers as argument. So for pointers, what do you pass? You pass the addresses. So A address is nothing but 100 is being passed to X. So X is a pointer who is going to be equipped with 100, which is nothing but the address of A. And when you're passing ampersand B, which is nothing but 200, will be when point to when we assign to 200 Y, so Y gets 200. So when I say asterisk X is nothing but X pointed value is nothing but 10. So by being here in this local scope, it is able to access the scope of other function. This is how the beauty of pointers you can probably see, right? So when I say t equal to asterisk x, in this case, what happens? T is a variable, temporary variable, which is a local to this particular function. Asterisk x when assigned to t, asterisk is nothing but x pointed value. X pointed value is nothing but 10 here, right? By being here, it is able to access the memory of other functions. That's how exactly you can able to access the memory of other scope with the help of the pointers, exactly, right? So 10 is being placed in t here temporarily. Then you are saying asterisk x equal to asterisk y. What do you mean by this? Value being pointed by y, which is nothing but 20, is placed in x pointed memory. X pointed memory is nothing but a. Here, so being here, you are changing, overriding the value of other scope memory, rather, right? You can see next statement is asterisk y equal to t, means t value 10 here. This 10 is going to be placed in y pointed memory. Y pointed memory is nothing but b here, rather, right? So here it's going to be placed. Now by being here, you are able to access the scope of other memory and then able to change the values of the same. And then when you are printing after swapping a and b values, what values are going to get? The interchange values of the same, rather, right? 20 and 10 you will get, right? Okay, here when you print it was 10 and 20 before calling the swap function, but then after calling you get about 20 and 10. Please turn off your videos sorry, audios. All of you, please turn off your audios. Pointer to a structure. You can have pointer to a structure which helps you to return the entire structure from a function or pass a particular complete structure to a function. This kind of advantages you get probably with the help of pointers rather, right? If I have here probably, let us look at a student structure. Okay, consists of rule number, name, and marks, right? What happens when you create a variable of student structure of stu one? Memory is going to be allocated for all its members. Name is one member for which 20 bytes and roll, integer 2 bytes and then marks integer 2 bytes. But then base address of the first one, let us say 4000. Then how many bytes will be allocated for this particular name is going to be 20 bytes. So from 4000 is going to be 4019, 4001, 2, 3. So the subsequent element address starts from 4020, 2020, 21. Then next is 4022, right? So this is how exactly the addresses are available. Also, this particular structure now you have created one pointer of the same kind of structure student, right? So for this pointer could be of any kind, but memory required for any pointer is only 2 bytes rather, right? Now you are saying pointer equal to ampersand stud1. Then what happens? The base address is nothing but 4000, which is going to be assigned to pointer. So you can see here, when it is assigned, this pointer can point to the entire structure, right? It can point to the entire structure here. How do you access the members of this particular structure? With the help of this membership operator called arrow. We sometimes call it as dereferencing operator, right? Dereferencing operator, or sometimes you call it as indirection or cap or whatever, or pointed to. Pointer, arrow. How do you get with the help of hyphen and greater than, right? So when I say pointer, you know, pointed roll, or I say pointer cap roll, or pointer index the roll. Okay, pointed row, whatever. So what it is doing, with the help of this pointer, you're able to access this particular member. If I want to access this marks with the help of pointer, then how do you access pointer, pointed marks? Another way of accessing the same is, this is another way, right? Asterisk pointer dot roll. Fine. Basically, with the help of simple structure variable, if I have to access any member of that particular structure, how do I access with the help of structure membership operator called dot, right? So stud1 dot name, I say, right? Stud1 dot name means you are able to access this particular member, right? So member dot is a membership operator rather, right? So this is one way when probably accessing the members of a structure with the help of a structure variable. But when you are trying to access the members of the structure, when the structure being pointed through a pointer is with the help of this dereferencing operator called arrow, right? And another way of accessing is asterisk pointer, within brackets you should give and then say dot. This is another way. So these are the two ways you can probably use to access the members of a structure when the structure being pointed through a pointer. Okay. And let us look at a program here. We have taken one student structure consisting of two members here, name and role. Now we have taken a variable of the same stu and a pointer of the same p, and placing the address of stu in p. Then what happens? This p can point to this entire stu, right? Stu must be having what? Stu must be having a STU must be having two members here, right? Name is one member, yes or no? Another one is role. If say name is starting with 4000, then 20 bytes means 4000 till up to 19, and then 4020 will be the role. So role consists of 2 bytes, right? So this is your STU. When I say PP is a pointer, then the ampersand STU, when you say the address, base address in the 4000 will be placed in P, then with the help of P you can point to this entire structure. How do you access with the help of this dereferencing operator, arrow, right? So while reading scanf, you just say P ampersand, P indirection name. Then since this is a string, you don't give ampersand here. But when you are reading the roll number, you must have to give ampersand p. Then you say indirection roll. Similarly, when you are printing, You can print using the p arrow kind of thing. That is, if you are using, you say p arrow name, and p arrow, in place of this you can just say p arrow name, so it will print the name. But if you want to access with another way of accessing, that is asterisk p dot name, you can use that rather, right? Those are the two ways, right? I can just say p indirection role, p arrow role, right? This way also I can access, or else I can access using this, right? So this is how about array with structure with pointers rather, right? I hope this is clear to all of you. Let us try to execute couple of programs here, which I have discussed here. I'll take the starting with the first one. I'll take the swap example. Is it okay? Let's execute swap example first. It's the online compiler here. Yeah, this program is basically to demonstrate all by reference, right? See, with the help of pointers, you can implement this call by reference explicitly. See, I'm using this function. I need to specify the prototype of the same. If I'm writing after the main, before the main, I have to give the prototype of the same. This is the prototype of it, right? Then after main, if I'm having the function, this is how I'm having this source code of the function after the main. Yes, sir. So if I'm having the source code of the function after the main, I need to specify the prototype of the same before the main. This is how exactly I've done it. And then probably run it and see if, okay, let us include stdio.h. Okay, and void main append. Enter two numbers. Before swapping, we are taking a and b values here. What values we are taking, the same we are printing, and then after we call the swap function again, after swapping we are printing the ab values here, right? So let us try to execute now. They are not double code actually. No, it is. Numbers. Okay, let us execute. Enter two numbers. Let us say I have entered 10 and 20. You can see here before swap and after swap, the values are before swapping A value is 10 and B value is 20. After swapping A value is 20, B value is 10. Right? I hope this is clear to all of you. Yes. We'll anyway stop here. The remaining examples are there. You practice at home as assignments. In the lab, we'll probably demonstrate and then have a look of the same. Okay. For now, we'll close. I hope all of you have given your attendance. If not, please give it immediately.